Hi guys, I'm live. I thought about it, and I think it's time for a math lesson. Um, I just think it is. I'm gonna do some other things tonight besides, or this morning, whatever we want to look at it. Besides this, but I thought I can do a math lesson. So here goes. Okay, so you have there's such a thing as the complex plane, otherwise known as an Argand diagram or a z-plane. The x-axis is real, so that would be uh, is equal to x plus x. The y-axis is imaginary, so that's iy. So a complex number is z equals x plus iy. So it's the sum of a real number and an imaginary number, which itself is a complex number. And one cool thing to do with this is draw a circle around centered on the center, and let's say the radius is 1. So this radius is 1. Um, then the equation of a so let's write this up here. If the radius is 1, the equation for a circle is x squared plus y squared equals r squared. Well, if r is 1, then you have x squared plus y squared equals 1, which is the equation of a unit circle, which means a circle of radius 1 around a plane, not an airplane, but a flat surface. And we know that this point is x plus iy in the if this is the complex plane. Now, we have x squared plus y squared equals 1, but from trigonometry, we have the well-known trig identity, which says that sine squared theta plus cosine squared theta equals r squared. It equals, no, sorry about that, guys. That equals 1. That's a trig identity. So if that's true, and if x squared plus y squared equals 1, unit circle, then we have, it's easy to see that if this becomes, that would mean that x equals, let's see, x equals, x can be cosine theta and y can be sine theta, and therefore the equation of a circle, which is x squared plus y squared equals r squared, in this case r is 1, so I'm going to write 1, is an equation of a right triangle. Because if you have a circle and you draw a radius, then and draw a line down, you have a right triangle. And that would mean that the x value could be either could be cosine x the real part, it's called part of a complex number, would be cosine theta. That's the x part, because the cosine is defined as the adjacent side over the hypotenuse. If the hypotenuse is 1, then the cosine theta is just the adjacent side of the angle. And then the y part would be sine theta, because the sine is defined as the opposite side over the hypotenuse. But in this case, the hypotenuse is 1, so sine theta is the y value. And we have if the, since cosine squared theta plus sine squared theta equals 1, that's the equation of a circle. So it's going to go around and around. And it can be deriven, not driven, through Taylor series, infinite series, that, which I'll write it up here. I'll write this can be driven from Taylor series, infinite series, which is actually Euler's formula. E to the I theta equals cosine theta plus I sine theta. We have that. And by the way, this right here is I sine theta. Okay, so we have this equation. Therefore, because of the circular relationship I just showed on the diagram, you can see that E to the I theta is equation of a unit circle on the complex plane. Okay, where the x part is cosine theta, the y part is I sine theta, and e to the I theta is basically z equals e to the I theta. X equals cosine theta, y equals I sine theta. So by x squared plus y squared plus z squared, since x squared plus y squared equals let me think. Yeah, we already showed that. So therefore, since a point on the complex plane is x plus iy, should say iy, not y. Right. Y equal I. No. Yeah. Iy equals I sine. Wait. No. Yeah. Iy equals I sine theta. So so you see that e to that theta equals cosine theta plus I sine theta. I think that's pretty clear, and you can see it graphically, and you can prove it mathematically with Taylor series. So now I'm going to do a few tricks here. I'm gonna write my complex plane again, and this is I, y, this is x. I lost my ability to write clearly about 30 years ago, lol. X. Okay, so theta is an angle that's measured in radians, and the angle that starts at 0 is the x-axis, and the angle goes counterclockwise. And it's measured in radians, meaning it's the length of the arc that's defined if you have if the radius is 1, then the angle is the length of the arc that is mapped out by the angle growing or shrinking from 0. So if I let theta equals pi, then since if the radius is 1, 2 pi is a full revolution around the circle, so therefore pi would be half a rotation around the circle, which would be at this point, and that would be that point is -1. Okay, because it's a unit circle and you're on the real axis but on the negative side, so we're at the point -1. I showed that graphically. Let's just show it graphically. Now let's do some math with it. Theta equals, yeah, so I'm letting theta equals pi, and you see that if theta equals pi, then z equals -1, which means e to the I theta equals pi equals cosine pi plus I sine pi. But cosine pi is 1, so cosine pi equals 1, sine pi equals 0, based on trig definitions. So therefore, let's go back up here with it. You have e to the I pi, e to the I pi equals 1, negative 1. Sorry, not 1, negative 1. We showed that already. E to the e to the I pi equals negative 1. Therefore, e to the I pi plus 1 equals 0. You're just adding 1 to both sides of the equation. And this equation right here is called Euler's identity. And I'm going to point out some things about it that I like. Sorry if this is long and boring, but, you know, it is what it is. This equation is beautiful. It has 0, which is the additive identity. X plus 0 equals x. It has 1, which is a multiplicative identity. X times 1, x times, this is x times 1 equals x. It has equals. It has addition. It has multiplication, and it has exponentiation. So it's got all three numeric arithmetic operations: addition, multiplication, and exponents. It's got 0 and 1. And not only that, let me write it down here. E to the I pi plus 1 equals 0. Not only that, it has e, it has pi, and it has I. Those are three of the most important constants in math. E equals 2.718281828, etc. Pi equals 3.1415925, and I equals the square root of negative 1. Very important constants in math. I could write this right. It's got 5 of the most important constants in math. It's got 0, 1, e, I, and pi. It's got addition, multiplication, exponentiation, and it's an equation. That's a very beautiful little formula called Euler's identity. What's interesting too is that it's been brought up twice on TV shows that I've known about. First of all, on Person of Interest, Finch is played by Michael Emerson, who brings it up in an episode of Person of Interest. He said that equation is like a sonnet. It means like a beautiful poem. Sasha Alexander playing Maura Isles on Rizzoli and Isles brought it up in an episode as well. That she said she liked Euler's number E. So there's that. Now one more thing. I'm going to drive one more thing, and then I'll be done with it. We'll be done with this math lesson. What is? Let's go back to the diagram again. Now, we said that if theta equals pi, you get 180 degrees, and it puts you on the x-axis on negative 1. But what if theta equals pi over 2? Well, that would make if theta equals pi over 2, then that would make that, and that's IY. That would be I, because the circle is radius. The radius of the circle is 1, so that would be the point I. If theta equals pi over 2, then E, let's do it like this. If theta equals pi over 2, then we have, using Euler's theorem again, or Euler's formula, sorry. E to the I pi over 2 equals I, because it's another way of looking at that. Another way of looking at that, deriving that besides the graphic visual way, is if you have e to the I theta equals cosine theta plus I sine theta, then e to the I pi over 2 equals cosine pi over 2 plus I sine pi over 2. And you know, well, it's longer than I thought it was going to be. Cosine pi over 2 is 0. Cosine pi over 2 equals 0. But the sine of pi over 2 is 1. Sine pi over 2 equals 1. So basically that means that e to the I pi over 2 equals 0 plus I times 1, or equals I. So there we have an important thing. Let's write it up here. I have yes. Okay. I have e to the I pi over 2 equals 0 plus I equals I. All right, here's what I'm going to do with that. This is going to be called, this is not Euler's anything. It's just a little formula. If I have e to the I pi over 2 equals I, what if I take the I power both sides? Then I have e to the I pi over 2 to the I power equals I to the I. Get that? I took the I power both sides. But e to the I pi over 2 to the I equals e to the I squared pi over 2. So follow that. And that means that from here we have basically e to the I squared pi over 2 equals I to the I. But I squared, let's erase this. But I squared is defined as, triple line means defined as -1. Or you can just write it the regular way. I squared equals -1. So e to the I squared pi over 2 pi over 2 equals e to the minus pi over 2. But that means that e to the minus pi over 2 equals I to the I. I'm almost done with this lesson. So I have, reversing both sides, reversing that equation left to right, I have I to the I to the I equals e to the minus pi over 2. That's a minus sign. Okay, that means that since I is an imaginary number, I to the I is an imaginary number to an imaginary power, which is equal to a real number, because pi is real, e is real, so e to the minus pi over 2 is a real number. That's interesting. And this is just an identity that I like in math. And since you have power over root in fractional exponents, you could say I to the let me get this. I'm almost done, guys. I to the I equals, first of all, e to the minus pi over 2 is 1 over e to the pi over 2. But since it's power over root, that means that would make this equal to 1 over power was e to the pi. The root is 1/2. So the root, yeah, the root, the fraction, the root is 2, but the square, the 1/2, the second, the second root is also called the square root. So e to the pi over 2 is e to the pi, but the square root of that. So basically, using your math skills, you can show that 1 over e to the pi over 2 is 1 over the square root of e to the pi, which is still a real number. So finally, we did all that. You have I to the I equals 1 over the square root of e to the pi. The root of e to the pi. Which is a real number. I forgot the value of it, but that's a cool identity there too. 1 over the square root of e to the pi. I to the I is equal to 1 over the square root of e to the pi. So I love you guys. Hope you enjoyed the lesson. Hope you learned something. Have a good rest of your day. Love you guys. Peace.